Section 3.5, Introduction to Matrices. The objective is the introduction to matrices and their operations. A rectangular array of numbers arranged in rows and columns and placed in brackets is an example of a matrix. That looks like this. The numbers inside the brackets are called elements. So each of these little numbers is an element. A matrix of order, M by N, has M rows and columns. So our rows go from left to right. That's row 1. This is row 2. And our columns from top to bottom. So this is column 1 and this is column 2. If M equals N, so if there's the same amount of rows as there is columns, then it is a square matrix. The example that I gave you is a square matrix. A general element in matrix A is denoted by A sub ij. This refers to the element in the ith row and the j column. So A sub ij is just a position. Example 1. Let A be the matrix with elements 5, -2, -3, pi, 1, and 6. What is the order of A? Order is another way to ask for size. And we are going to count the rows first, then the columns. So we're looking at rows. We have 1, 2, 3 rows. So this is going to be 3 by, and we have 1, 2 columns. So we have a 3 by 2. Question B, identify A sub 1, 2. So this is asking us for row 1 and a column 2. We look for row 1 and a column 2. The element we are looking for is -2. C, identify element A sub 3, 1. We're looking for row 3, column 1. So we have 1, 2, 3, and column 1, we are looking for this element. Equal matrices. Two matrices are equal if and only if they have the same order and corresponding elements are equal. So let's take a look at example 2. We have 3 matrices, A, B, and C. Question A asks, is A equal to B? One of the first things we need to compare is the same order. So it's asking us to look at the size of each matrix. Matrix A is a 1, 2, 3 by 2, 1, 2. Matrix B is a 3 by 2 as well. And it tells us that we have to have corresponding elements. So now we're comparing each element. So we're looking at this 5 is 5, -2, -2, -3, -3, and 1/2 and 0.5. Those are equal. And we're looking at 1, 1, 6, and 6. Therefore, these two matrices are equal. A equals B is true. Take a moment to think about, is A equal to C? Don't forget to compare the size first, then each element. Let's dive in. This is a 3 by 2 as well, and we are comparing A to C. Is 5 equal to 3? It is not. Therefore, A is not equal to C, and the answer is false. Example 3, it says, given that A is equal to B, that tells us that they're going to be the same size, the same order, and they're going to have corresponding elements. What is X, Y, and Z? So they're already telling us that they are equal, but let me make sure that we have the same size, which we do. And that means that x is equal to 1. So we have our first answer. Y plus 1 is equal to 5. So I need to work that out a bit. Y is equal to 4. And Z is equal to 3. 0.5 plus 1. 8 plus 16.